In today's video, we're still going to be talking about 3D vector analysis, but here we're going to be solving the problem on Cartesian form, okay, or vectors in Cartesian form. Now we'll talk about vectors in Cartesian form. There are several vectors that they are not giving the resultant, but rather they are giving various components. That is the x, y, and z, or the I, j, and the k components. In this case, we're having I, j, and k, and j and k as well. Okay, now what you want to ask yourself is, how do I resolve vectors in Cartesian form? Okay, now how is that being done? This diagram is not really drawn to scale, it's not drawn perfectly, but I'm going to explain what is on the board so you guys get it. Okay, so here we're having the x, y, and here is the z as x. Okay, this is y, x, and z as it, and here is negative y. Okay, now negative z is down and negative x is inside of it. Now we're having a force between z and y, that's 60J plus 80K, okay, and then we're having a force here that is just between negative y and x. That is why you're seeing these two lines here joining the negative y and x. Then from here we're having the tip just to the point of the vector. Okay, it's a force because they are measured in pounds. That's lb. Okay, so now f2 is 50J 50I minus 100J plus 100K. Okay, that's what we are seeing. It has both heights and x and y components. Now, how do we solve vectors in Cartesian form? Now, to solve vectors in Cartesian form, we simply add them. That's step one. Okay, so to solve vectors in Cartesian form, I'm going to write here, to solve vectors in Cartesian form, we simply take the sum of each vectors. Okay, all we simply do is take the sum of each vectors. Now here's what we're going to do. We're going to say sigma f of r will be equal to the x component plus the y component plus the z component. Now notice that in our previous video, while explaining how to get the resultant force or the resultant vector, we took the square root of the square of the individual component. That's when it is not in Cartesian form. Whenever you are seeing I, j, and k, all you have to do is take the sum of them. And in this case, in that case, your answer is still going to remain in what now? In Cartesian form. Okay, that's what we're going to do. Now, to solve a problem like this, we're going to say sigma f of r, okay, is equal to, now every x component and every y component and every z component as well, we're going to be taking the sum of everything. So when I add all of these, we're going to have 50I minus 100J, okay, plus 100K, okay, and what else? We're going to add 60J rather, 60J plus 80K, okay. Now when I do that, what do I get? Now there is no I component for this, so 50I remains. We're going to have 50I. Now 60J minus 100J gives you minus 40J, okay? And then 80K plus 100K gives you 180K. Now here is simply the value, okay, of the resultant vector for this question, okay? All you have to do is add it. Very easy. But the question does not stop there. Now, sometimes, or majority of the times, you'll be asked to find the direction of this final resultant vector. Because, of course, anytime we find a vector, you're usually told to find the resultant, okay? Now, to do the resultant is pretty easy, okay? What we'll do, we're going to equate these various functions, okay? Cosine of alpha, sine of beta, cosine of alpha, cosine of beta, and then cosine of gamma into these guys, but not just these guys, into the unit vector of these guys. Now, what is simply a unit vector? A unit vector is simply that vector, okay, in which its magnitude is equal to 1. And how do we obtain the unit vector? What we are going to do is we're going to find the magnitude of this vector at first, okay? So I'm looking for a single vector first, and the single vector is giving us the magnitude of this summation we just obtained, okay? Now it's going to be equal to the square root of each of these squared and taking the sum, okay? So we're going to have 50 squared plus minus 40 squared, okay, plus 180 squared. Now you notice how I put this one in bracket. This is because you should not tamper with this negative sign, okay? It is very important. For that reason, I'm going to be putting it in bracket and squaring it. such that you don't mistakenly bring out the negative sign outside. Okay, that's a very good advice, because most students tend to make mistakes when it comes to this point. Okay, so we're going to be solving this, and we'll resolve each of these. Okay, we're going to have sigma f of r, and that is going to equal, okay, so we're going to have 50 squared squared gives us 2500. We have 2500, okay, plus minus 40 squared. The minus is going to leave because of the squared, so I should be having 16,000, and then 180 squared. 180 squared should give us 32400. Now we'll press this every single thing we're having here in the calculator. 2500 square root of 2500, okay, square root of 2500 plus 1600 plus 32400. Okay, we're going to get 10 root 365, which is in decimal equal to 191.0 okay, I'm going to leave it in two decimal places. Actually 191.047 and 497. Okay, now what will now be the unit vector? So the unit vector, which will help us find the direction, unit vector will be this vector we just obtained divided by what now? The magnitude. Okay, so the unit vector is going to be equal to 50i over 191.05, okay, minus 40j over 191.05, okay, plus 180k over 191.05. okay, that's also I'm simply going to get. Now you could choose to reduce this guy to decimal, of which I'm going to do as well. So we have 50 divided by this answer, we're going to get 0.262i, okay, minus 40 divided by 191.05, that's going to give us 0.2094, okay, plus 180 divided by 191.05, you get 0.9422k. okay, now this for j. Now here is the unit vector we just obtained. So what we're going to do is equate this function to the one for I, equate this function to the one for j, and equate this to the one for k, then we'll get our direction. So the direction for the x-axis, we're going to have cos alpha equals 0.26, okay, 0.262. So alpha is cosine inverse of 0.262. That's going to give us the cosine inverse of 0.262 gives us 74.81 degrees. Okay, that's to the x-axis. So this vector is having an angle of this guy to the x-axis, and then that of the y-axis is going to equal minus 0.209. Do not forget to include the negative sign, very important. Okay, so the cosine inverse of minus 0.2094, okay, that gives us an angle of beta equals 102.09 degrees to 2 dp. Okay, and then for gamma, this one is the angle to the y-axis, and the angle to the z-axis is going to equal 0.9422. okay, so gamma equals the cosine inverse of 0.9422. okay, that's going to give us 19.58 degrees. Okay, so basically those are the angles, okay, and this is the results. Okay, so this is the Cartesian form of the resultant vector, and this Cartesian form has an angle of this to the x-axis, this to the y-axis, and this to the z-axis. So basically this is an example that helps us understand how to solve vectors in Cartesian form. Okay, now in our next video we're still going to talk about vectors that are having inclinations using triangles, okay? Or we're going to take problems, probably a pulley or a hole, and how we apply every of this example that we'll be doing. Okay, we're going to apply a lot of knowledge we've learned so far into those next few questions. Okay, now if you have a question, do it to put it in the comment section as usual. Okay, like, share, and subscribe to the videos to my channel, and share the videos to your friend as well, so you don't let them know. Now, most importantly, do it to click on the notification bell so that when I upload a new video, okay, you'll be one of the first few persons that get to access these videos and learn from it. Okay, so in our next video, we're still going to be talking about the 3D vector analysis, okay, but a different example or a different approach to the various problems.